Okay, question 6. Two technicians, L and M, want to measure the speed of sound in air. L fires a starting pistol. Let's give him a gun. Boom. M starts a stopwatch. Let's give them a stopwatch. When they first see the smoke, poof, there we go. They stop the stopwatch when they hear the bang. Okay, fine. So we know it's only going one way. So therefore we're going to need shoot Donald Trump. The distance is 120, tells us that in the diagram. M's reaction time is 0.23. The speed of sound in air is 330. Okay, so shoot Donald Trump. Calculate M's reaction time, which is 0.23, as a percentage of the time it took. So we've got to work out the time. So it's going to be that divided by whatever time I work out times 100. So our first job then is to work out the time it took. So the time it took is 120, that, divided by the speed. You can see that here, so distance divided by speed. We've worked out then that that took 0.3 seconds, and then we want to do their reaction time as a percentage of this. So 0.23 divided by 0.36 times 100, 63%. Which of these would improve the technician's measurement of the speed of sound? Use a firework banger instead of the starting pistol. Use a stop clock that measures time in minutes. Increase the distance, absolutely, because it will mean if we increase the distance, it will reduce the percentage error from their reaction times. Because the big source of error in all of this is the systematic error from human reactions. So yeah, C. Next one, figure 10 shows the difference in refraction of sound and light. So we can see sound when it goes into water goes away from the normal. Light goes towards the normal. The basic idea is we've got a difference in densities. Sound, its speed increases because it's easier to transfer its longitudinal wave because the particles are closer. And light, its velocity decreases. And then we've got it. So this one's going away from the normal, that one's going towards. This one's because the sound speeds up in the more denser medium, and the light slows down in the more denser medium. So we've got those basic ideas there. So refraction is caused by changing density, causing a change in speed, and that was in the mark scheme. So in both of them, they're having their speed changed. Light slows down, entering water, so it refracts towards the normal. That. Sound speeds up entering the water, refracting away from the normal. Quite a tricky question, actually. It's a nice question, but it's not particularly easy. This one's lovely. Light is an example of an electromagnetic wave. Describe two other electromagnetic waves. So red, monkeys, insert vultures, under xylophones, great. Long waves to short. You've just got to pick two of those, name them, and then say something about their uses. So I'm going to go microwaves, used for mobile phones and cooking, done. Ultraviolet, used for sterilising water, suntans, security market. So I think that's a lovely question.